All right, I wanted to just show you on number 13. I showed you in the last video how to just write it out in a very elementary way, which is totally fine, believe me. But the whole point of giving it to the seventh power is it wants you to kind of show, it wants you to solve it without having to write it all out. So I just want to show you that just so you have that option. Okay, so when it says the seventh power, it's in n, choose k minus 1 is what you're doing. The n is the power, or n minus, the n is the power that you're doing, which in our case is 7, and the k is the number, the number term that you're looking for. In our case, it asks for the third term, so it's 3. So what this is, in order, because remember we were looking for that 21. So that 21, the way we got that is, should be at the power is 7, and the term is 3. So 3 minus 2 is, or 3 minus 1 is 2. So it's at 7, choose 2. If you're not sure what this looks like or how this is a calculator, definitely you can put it in there, but it's not that hard. So let me show you how it works. 7 choose 2 just means this. 7 factorial over 2 factorial, and then 7 minus 2 factorial, which is 5 factorial. Now, what does factorial mean? The factorial means this: 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, your calculator can handle all of this. The 2 factorial just means 2 times 1. 5 factorial, what does that mean? 5 times 4 times 3 times 2 times 1. Now, it's really convenient because obviously those cancel out with this. And then you end up solving this. So I would have 7 times 6 is 42. Divided by 2 is 21. So that gets me my 21 number without writing everything out. So you may say, okay, then how do I get everything else? Because so this, the way I got everything else is because it's my third term. Remember, I'm starting, so instead of 7 minus 3, I'm starting with my 7 minus k minus 1 to get here, and this is my k minus 1. So if I were to actually give you a formula, it'd be this: n choose k minus 1, and then my first term, which is my first term is going to be, if I'm sorry, let me just write it out like this. If I have an a plus b to the n, okay? So, and if I want for an a plus b to the n, and I want my third term, or fourth term, or fifth term, or whatever it'd be n choose k minus 1, and then this would be a to the k minus 1, the n minus k minus 1, b to the k minus 1. Okay, so when let's do all our stuff in here. So this was 7, this was 3, so this was going to be 7 choose 3 minus 1, which was 7 choose 2. And then a to the n to the k minus 1 was going to be my a in my problem was 2x, n 7 minus the k minus 1 again was 2, because that's k minus 1, 3 minus 1 is 2. And that's where I got the 5, so 2x to the 5th. And then b to the k minus 1. So it's going to be b for mine again. My b in my problem was y. And the k minus 1 is 2 again. So that's where I get y squared. So we saw that that is just 21. 2x to the 5th, y squared. So that's the technical way. They're trying to show you how to do it, but again, you can use the Pascal's triangle is what I did as well. All right, let's move on to number 14. Use the fundamental counting principle. All right, in a plan of area codes, the first digit could be any number from 2 through 9. Okay, so I've got first thing can be from 2 through 9. The second digit was either 0 or 4. So this could be 2 through 9, and this one could be 0 or 4. And the third digit could be any number except 0. So it could be 1 through 9. With this plan, how many different area codes were possible? Okay, so with 2 through 9, you see how many digits are there between 2 and 9? Well, you can say how many digits are there between 2 and 9? You can say, well, 2, 3, 4, 5, 6, 7, 8, 9, if you count them up. you get 8. 0 or 4, there's only 2 possibilities. And 1 through 9, how many are there for 1 through 9? Say there's 9. There's 9 numbers. If you multiply that all out, 8 times 2 times 9, you get 144. So that's all you have to do for that one. Okay, an ice cream parlor has 33 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each of a different flavor. So how many such bowls are possible? Okay, so I have 1, 2, 3 scoops. So if you walk into the ice cream parlor and you say, I want an ice cream bowl with 3 different types of ice creams. And they say, okay, well, what would you like? And you're trying to say, well, I'm trying to get all the different possibilities. So how many choices do you have on the first flavor? It says it has 33, so you have 33. Okay, so you have 33 choices. Well, now you've chosen, so you had 33. So now you've chosen one of those, right? So if you've chosen one of them, let's say you chose chocolate. You can choose everything now except chocolate. So now you only have 32 choices for the second scoop. And let's say you chose vanilla, just for, let's say that was chocolate and that was vanilla, just for easiness sake. So now you can choose anything except chocolate or vanilla because you are asking for a bowl of ice cream that has 3 different scoops of ice cream. And so now you only have 31 choices left. If you multiply all that out, you get 5,456. Okay. Number 16, 11 jokes are listed in a magazine. And how many ways can people select their 2 favorite jokes from this listed? So it says I have 11 jokes, and I am wanting to know in how many ways can people select their 2 favorite jokes from those listed. I've got 11 people, and so how many can I do? All right, so if I've got 11 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh,